Hey guys, it's Easy as Pie here, and today we're going to be looking over solubility calculations in level 3 aqueous. So if you're unfamiliar with level 2 aqueous, the most important concept to cover is equilibrium constant. So the equilibrium constant for a reaction gives us the ratio of products to reactants. So you can see in this equation here, we've got the concentration of our products, C and D, and we divide it by the concentration of our reactants, A and B. So in level 3, we're introduced to something new, which is a solubility product expression. Now what this is basically the same as our Kc, or equilibrium constant. The only difference is we only use the solubility product expression when we are dissolving something, so like an ionic compound. As you can see here, we've got sodium chloride and it's dissolving to produce Na plus and Cl minus. If we were to write our equilibrium constant equation, it will look something like this, where we've got our products, Na plus and Cl minus, over our reactants, which would be NaCl. However, if you remember from level 2, we don't actually include solids or liquids in our equilibrium equation. So for this specific equation, we would take out the NaCl. So we would have our solubility product expression is equal to the concentration of Na plus multiplied the concentration of Cl minus. So before we go any further, I just want to give a brief overview of how we actually measure the solubility of something. So as we previously talked about solubility in level 2, we always described something as insoluble or soluble. However, in reality, the solubility of a compound can vary from very soluble to insoluble. And how we measure that solubility is the amount of moles of a salt that will dissolve in a given volume of solvent. So let's use the example of table salt here to figure out what exactly this definition means. So if you've ever done a similar experiment in class or at home, you'll know that when you add table salt to water, it initially dissolves. However, the more you add, something will occur later on. So once you add a specific amount, you can no longer dissolve any more sodium chloride. In fact, what begins to happen is you have a precipitate building up. Now, the solubility of sodium chloride is the kind of the maximum amount of sodium chloride that actually dissolve in the water. So we're not taking the precipitate, we're just taking the amount of sodium chloride that actually dissolve to give us Na plus and Cl minus ions. So for now, let's denote this as S. And remember, our S will be a concentration. So how many moles of a salt would dissolve in a given volume? And so we can do some calculations with simple equations like this to figure out our solubility product. So for example, in this equation, we're given the solubility of sodium chloride, which is 1.87 times 10 to the negative 4. So first of all, what does that mean? Well, basically we're told that the concentration of sodium chloride that actually dissolves in water is 1.87 times 10 to the negative 4 moles per liter. But how do we use it to work out our Ks if we don't have sodium chloride in our Ks expression? Well, if you look at this equation here, we can see that when we have 1 mole of sodium chloride, it gives us 1 mole of Na plus and 1 mole of Cl minus. Because all the Na plus in the solution is formed by NaCl dissolving, we know that the two concentrations are exactly the same. So we know that the solubility of NaCl, or the concentration of NaCl that dissolves in water, is equal to the concentration of Na plus and the concentration of Cl minus. So now that we know our values for Na plus and Cl minus, we simply put it in our equation to get our answer. Now, an important thing to note for these type of questions is, just like Kc, you don't put units on Ks. And so remember back in the beginning of the video, we talked about giving the concentration of our solute some arbitrary concentration of S. So we know that the concentration of our ions is the same as our solute. So they will also be S. So we know the concentration of Na plus and the concentration of Cl minus will be the exact same as the solubility of NaCl. And so if we were to write that in an equation, we can see that the Ks of this specific equation is equal to S, so the concentration of Na plus, multiplied by S, the concentration of Cl minus, and that gives us S squared. But what if we have something a little different? So the key thing to take away in this equation is we have 1 mole of reactant producing 1 mole of Mg2 plus, but it produces 2 moles of hydroxide. So this actually makes our life a lot more difficult, and you'll see why in a second. If we were to write the solubility product expression, we would get something like this. So the concentration of Mg2 plus and the concentration of OH minus, and it's squared because we have this coefficient of 2 over here. However, if you remember from the sodium chloride example, we knew that the concentration of MgOH2, we knew that the concentration of the reactant was the same as the concentration of all our ions. But that isn't the case here. We know that if we have 1 mole of magnesium hydroxide dissolving, we will get 2 moles of hydroxide formed. And so the actual concentration of OH minus isn't just S, it's actually 2S, or 2 times the concentration or solubility of magnesium hydroxide. And so inputting our values for our solubility product expression, we have S, which is the concentration of Mg2 plus, and we have 2S, which is the concentration of hydroxide. So we have 4S squared multiplied by S gives us 4S cubed. And that gives us our general expression for Ks when we have a formula like magnesium hydroxide, where not all the coefficients are equal to 1. So let's take an example of calculations when we have an equation like magnesium hydroxide. So if the solubility of magnesium hydroxide is 1 times 10 to the negative 3 moles per liter, what is the value of Ks? Well, the first step for us to figure out is which equation do we use? We would use this equation because we have ions in a ratio of 1 to 2, rather than simply having 1 mole of this ion and 1 mole of this ion. Secondly, we have to figure out what exactly do we plug in. Well, we know S is the solubility of our reactant. In this case, it's magnesium hydroxide. So we can simply plug in S into this Ks expression, which will give us 4 times 10 to the negative 9. Now, remember, for these type of questions, it's important to use the calculator correctly. So it would be very easy for you to put this into the calculator wrong. Let's say you multiplied the 1 times 10 to the negative 3 by 4, and then you cubed it, that would give you a very different answer to 4 times 10 to the negative 9. So just a brief overview. Solubility is pretty simple in terms of the calculations that you have to do. What makes it so difficult is interpreting a question and figuring out exactly what you're trying to calculate or figure out. In addition, there's a lot of ways to make mistakes. Starting with first would be just general units. So remember that KC, KS, they don't have units. You have to put in your solubility units all the time as mole per liter. So there's a lot to remember, and there's a lot of ways you can mark up. So in saying that, the way to kind of overcome this is just to do a lot of practice. You can do a bunch of past papers, and eventually you'll iron out all the mistakes that you've made. And finally, it's important to understand what exactly you're doing. So for solubility specifically, it's a good idea to kind of understand what solubility is. So what does it mean when we say the solubility of a compound is this concentration? And the reason why is the examples we've done today are pretty simple, but in NCEA, they'll try their best to trick you up. So for example, they might not ask you for the concentration of the reactant. So they might not always ask you this style of question where you have to calculate Ks. They might ask you to work backwards to calculate the solubility of magnesium hydroxide. Or they might ask you to calculate the concentration of the Mg2 plus or the OH2 minus. And ultimately, if you understand what exactly you're doing, what exactly solubility means, then you'll be able to figure out how to do all these complex equations. But yeah, otherwise, I hope the video was helpful, as easy as pie, and yeah, thank you.